Kinetics is concerned with the relationship between the forces acting on an object and the motion of the object. It can get quite complicated, but lucky for us, we're looking into the kinetics of particles. We can treat objects as particles. It doesn't matter what shape it is, whether it be a box, a cat, or a banana. We're only concerned with the motion of the center of the mass of the circle. No need to worry about air resistance, rotation of the objects, and other complicated stuff. To start off with this topic, let's start with the most basic, and that's Newton's second law. For those unfamiliar, the equation is F equals to ma. A force is applied to an object and the object accelerates. Here's an example. A box with a mass of 10 kilograms is acted on with a force of 10 newtons. What is the acceleration of the box? Assuming no friction, we can use F equals to ma, rearrange and find out the acceleration. And don't forget your sign convention. Let's move on to something more complicated. A force is applied in lifting up a heavy box. We're analyzing the box, so let's isolate the box and draw the free body diagram. All forces acting on the box must be included, which includes the tension of the rope, the weight of the box, and finally the acceleration. All these can be put into an equation. All forces on one side and the acceleration on the other. But what if I add an extra object into the box? Easy. The object inside the box can be considered as 1, so the only change in equation is the mass. With the extra object, we will need to add the mass of the object and mass of the box together. It might be easier to put it in numbers. The force is applied accelerating it to 2 meters per second squared. The box weighs 10 kilograms and the object weighs 3 kilograms. Determine the force acting on the rope. Again, using the equation, tension going up, downwards is weight of cat and weight of box. Right hand side we have acceleration of cat and acceleration of box. Rearranging and voila. Tension is equal to 153.53. But what if there are two different objects? Then we need to split both objects into separate free body diagrams and create individual equations. But wait, acceleration of the doll is just the opposite of the acceleration of the cat. And tension of the rope is same throughout. Knowing this fact, we can create individual equations of both these objects and put them together into one equation. Both the t's cancel out. Now we have to do some simple substituting and rearranging, and we can work out the acceleration. Now let's introduce something else. It's friction, a force that opposes the motion between two surfaces. Like when you push a box, it's hard to push not only because it's heavy, but also because there's friction between the surface of the box and the surface of the floor. Back to the first question we did. This time we include friction. We have two forces acting, the weight of the box pushing down and the reaction force or normal force of the floor pushing back up equally. Now if you apply P amount of energy pushing the box, there will also be friction force going against the motion. But how much is friction pushing back at us? It's F equals to mu times n many. This equation shows that friction is proportional to the reaction force n and is independent of the area. So how hard it is to push the object is determined by its weight only. Mu is the coefficient of friction and it's categorized into static friction, which is not moving, and kinetic friction, which is moving. During the object's static phase, as you increase P, mu static also increases along with it to balance so that there is no acceleration. But eventually P will be big enough to overcome the friction and the object starts moving. Here, as the object is set in motion, its continued motion becomes easier. While it's moving, it's turned into coefficient of kinetic friction, a constant. Think about it this way. You try to open a jar of jam. While it's static, it's incredibly hard to open. You have to put more and more force into it until it pops open. That pop is the change from static to kinetic friction. Now it's past the hardest point. The rest of the lid is easier to open. And we can represent this on a graph. Let's do a question on this. P equals to 100 newtons, mass equals to 10 kilograms, the coefficient of kinetic friction equals 0.5. Find its acceleration. What's the acceleration? I don't know. I'm too lazy to narrate anymore. This video is done for an assignment and made by me.